Hi everyone. So today we are going to learn about how to organizing and graphing quantitative data. So as we can see here, there are quite lots of things we are going to learn today. So this is the topic. So first of all, we have frequency distribution. And then for frequency distribution, it is divided into two: group data and ungrouped data. And then we have cumulative frequency distribution, relative frequency distribution. And then for graphing quantitative data, we have histogram, cumulative frequency polygon, and the last one is stem and leaf plot. Okay, so let's focus on the very first subtopic we have here. So for organizing quantitative data, first we have frequency distribution. For frequency distribution, we have the first one for ungrouped data and then the second one for group data. So how are you going to differentiate between these ungrouped and group data? So let's take a look at the example for ungrouped data. So in table 2.8, the number of car owned by 40 families at Taman Ria. So as you can see here, we only have number of families. So this is the frequency. The symbol we are going to use for frequency is F. And then we have variable, number of X. Sometimes the variable, we label it as X or Y, depends. And then we have the classes. So for the classes here, we have maybe some of the families, for example, right here, they do not have car at all. So two family doesn't have any car. And then no family have more than more than 3 cars. Because right here we see that 3 cars, yes, there are 4 family have 3 cars, but then for 4 cars, no one have more than 4. So this is for ungrouped data. But then if we take a look at table 2.9, so this is the example for group data. As we can see here, we also have frequency, F. And then we have time spent on reading in a day, time in minutes. But then the classes here, there is a little bit different between these two examples for group and ungrouped data right here. For classes, for group data, it is in terms of interval. So the lower limit for the first class is 1 to 5. 5 is the upper limit, 1 is the lower limit. So for the second class, we have the lower limit 6 and then the upper limit 10. And then we can see the number of children. So this is quite different from ungrouped data. Ungrouped data, there is no lower limit or upper limit. Okay, I hope it is clear for you guys. And then for group data, there are 2 kinds of table. So we need to be very clear right here. So table 2.10, frequency distribution, the class interval given here is 5 to 8. And then for class frequency, this is usually given by the question, so you don't have to calculate for class frequency. But then for class boundaries, you can see here, the lower class boundary for the first class is 4.5, and then the upper class limit is 8.5. So how they calculate these class boundaries? So we imagine that before this class, we have another class. So the upper limit for the class before the first class is 5. So before that should be 4, maybe 1 until 4. Okay, so the formula for class boundaries, the upper limit of the class before that, so in this case we have 4, plus the lower class limit of the next class, so for this case 5, divide by 2, so you're going to get 4.5. That's why the class boundary for the first one is 4.5. And then why the class boundaries, the next one is 8.5, the formula is quite the same, is actually the same. So we got here the upper class limit of the class before that is 8, plus with the lower class limit 9 divided by 2. So if you calculate it, you're going to get 8.5. That's why the value is 8.5. So this is also the same for 16.5 right here. Why is it 16.5? Because the value here, 16 plus 17 divided by 2, you're going to get 16.5. And then why the last class boundaries value is 20.5? Because we assume that we have another class after this one, so the next number should be 21 up to maybe 21, 22, 23, 24. So 20 plus 21, so this one is 20 plus 21 divided by 2, so you are going to get 20.5. So that's how you need to calculate class boundaries. So for class width or class size, the symbol for this one is C. Class size. So how are you going to calculate the class size? You just simply take for the class interval for the first class is 5 to 8. So how many number do you have here? 5, 6, 7, 8. So 4 numbers. So the class size or the class width is 4. And then for the class midpoint, this is also a very simple calculation. So the class interval is 5 to 8, 5 to 8. So to calculate the class midpoint, the symbol for the class midpoint is X. So you just simply need to total up 5 plus 8 divided by 2. So in this case, you're going to get 6.5. Okay, so that's the first table of the first kind of frequency distribution. But then, as you can see here in table 2.11, the class interval is quite different from 2.10, from table 2.10, because right here, then the class interval in terms of 3 less than 7. So 3 less than 7. Or 3 less than 7. So for the class frequency, this is usually given based on the question. And then for the class boundaries, you don't have to calculate it. So if you notice the pattern here, it is actually the same with your class boundaries. So you don't have to calculate for this kind of table. But then for class midpoint, so for class midpoint, what is the formula? Can you guess it? It is actually the same with the previous one. Class midpoint, the symbol is C. So let's say the first one is 3 less than 7. So 3 plus 7 divided by 2, you are going to get 5. So the class midpoint is 5. And then for the class width, the symbol for class midpoint is actually X. The class width is also called as class size C. So why the class size or the class width is 4? For this kind of class interval where we have the class interval 3 less than 7. So the number we have here is 3. 3 less than 7, yes. 4 less than 7? Yes. 5 less than 7? Yes. 6 less than 7? Yes. But 7, is it 7 less than 7? No. 7 is actually equal to 7. So this is wrong. So the class size or the class width is 1, 2, 3, 4. That's why the class size or the class width is 4. For detailed explanation, you can read it from the books that you have. Okay, so why it is very important? Because the graph that we are going to draw after this, histogram, cumulative frequency distribution, everything depends on table, the calculation that you have in the table from the frequency distribution. So the class boundaries, we are going to use the class boundaries as the x-axis in your graph later. Okay, so that's all for frequency distribution for group and ungrouped data. So the next part, we are going to discuss about the cumulative frequency distribution and relative frequency distribution. Okay, let's discuss about the relative first. So for relative frequency distribution, the question usually are going to ask you construct a relative frequency distribution, and then the first two column is actually given, and then the fraction, decimal, and the percentage column you need to calculate it. And then for fraction 1/10, the value 1/10 is actually come from the number of students 4 divided by 40. 40 is the total, that's why you get 1/10, and then you calculate the decimal, and then you calculate the percentage. So that's all about relative frequency distribution. So the next one, cumulative frequency distribution. So if you look at the table 2.12, as usual, test score and number of student is the frequency. This is given in the question. So you need to calculate the less and upper boundaries, the cumulative frequency, and then the last one is the cumulative relative frequencies. So how do you calculate the less than upper boundaries? So this one we actually discussed it before, so you need to refer to the notes before this. So after you calculate the less than upper boundaries, if you don't remember, let's take a look at the calculation. So which one is the less than upper boundaries? So less than upper boundaries for the previous example is this one. So if you can see here, I'm labeling starting from 4.5 up to 20. So 4.5 up to 20.5. So this one is actually the calculation for less than upper boundaries. Starting from here, so this is the classes. After you calculate the class boundaries, the value that you need to take is from this highlighted green here. So the first class boundary is 34.5. So how are you going to calculate the cumulative frequency? So the first one, you need to know the first two column here is empty because this is actually not exist. So if I'm going to ask you how many students score less than 34.5, actually there is no classes before this, so the answer is 0. No students scored less than 34.5. So the next one, how many students score less than 43.5? So 43.5 right here, only 4 students. So that's why it is 4. So how many students score less than 52.5? So 52.5 somewhere right here. So you need to total up everything, so you get 9 here. That's why the cumulative frequency is 9. So this is also repeatedly happen to the rest of the classes. So after you calculate the cumulative frequencies, you need to calculate the cumulative relative frequency. So this is also quite simple. The first one, 0, because 0, this is actually 0 divided by the total here, 40, but then 0 divided by any numbers, anything you divide, 0 is 0. And then the next one, 4 divided by the total, so 4 divided by 40, so you get 10%. So this is also the same to the rest of the cumulative relative frequencies. Okay, so that's all for organizing quantitative data. So the next part of this chapter is actually to draw the graphs. So the first one we have here is histogram. So actually this is quite simple. If you already calculate all the values that we need before this from the frequency distribution, so you only need to apply. So the first one, after you got the class boundaries and then the number of student F, you only need to draw. So the first class boundaries, 29, so right here we have 29. The highest class boundaries is 99.5, that's why the value here 99.5. And then you need to label. The label depends on the question. For this question, it is marked test score that we previously discussed. So the y-axis is actually the number of students. So this is come from the second column. And then you need to label your graph. The first bar, where do you get this value? The first bar, the number of students who scored less than 39.5 is actually 4 students. So this is 4. We just draw 4. So the next number, 5. So somewhere right here, 5. So you just draw. So this is quite simple. I hope you get it. Okay. So after histogram, we have frequency polygon. Histogram is actually, it is quite simple to get frequency polygon if you already have your histogram. So based on histogram that you have from the example in your book, so this is histogram. The blue part here, the blue bar here is actually your histogram. So how do you want to draw your frequency polygon? You only need to put the midpoint at the bar, each bar, and then connect the dots. But then you have to remember you need to put extra class at the beginning of the graph and then at the end of the graph. So this is your frequency polygon. So the next one, we have cumulative polygon. So this is actually quite simple. So this is based on the question. So the question only gives you marks and the number of students. So number of students is the frequency. But then in order for you to draw cumulative frequency polygon, you need the y-axis is actually cumulative frequency. The word here, cumulative frequency polygon. So y-axis, cumulative frequency. So x-axis is actually your class boundaries. Okay, so you need to calculate the class boundaries. So you calculate the less than upper class boundaries. So for this case, you calculate the class boundaries. So the first one is 29.5. So how many students actually score less than 29.5? So if you look at this table, there is no student who got marked less than 30 actually. So the number of students is 0. So how many students score less than 39.5? There are 4 students. So that's why the next cumulative frequency right here, 4 students. So how many students score less than 49.5? So this one 49.5. So you total up everything, you got 9. That's why the value here 9. So how many students scored less than 59.5? So right here 59.5. So you total up 9 plus 9, 18. That's why the number of students 18. So the calculation is actually the same for the rest of the values. So after you have the cumulative frequency and the class boundaries, you only need to draw the graph. So the first value 29.5, and then the highest class boundary 99.5, and then you need to label the class boundary right here, the marks. So in this question, it is about the marks, so you need to label according to the question. And then for y-axis is the number of students. So the first value we have here is 0. So how many students score less than 29.5? It is 0. How many students score less than 39.5? The value is 4. So 4 is somewhere here. So you connect the dot after you carefully find the point for each. So this is your cumulative frequency polygon. I hope you understand everything, because this is the last one we have here. The last one for today is stem and leaf plot. So this is the simplest topic we have, stem and leaf. So this is the example of stem and leaf in figure 2.1. So we only have two division here, stem and leaf. So this is actually quite simple, the group values and then the individual values. So the stem is actually how they group the values, and then the individual values is actually, so the first one, let me tell you the value, the actual value: 10, 15, 21, 23, 23, 24, 32, 35, 38, 40, 40, 41, 43. So the characteristic of stem and leaf, first you need to arrange the value. Second, you need to divide based on the stem and leaf. So the stem and leaf is actually, we simply need to have one digit to be the leaf. So the first value, when we divide the number, so 1 is actually the stem, 0 is actually the leaf. So everything here is the same. So when you need to convert this data into stem and leaf, those who have the stem value, the same stem values, right here we have 1, 2, 1, 4, 0, and 4, 5. So you just need to draw it like that. And then the next number, 21, 23, up to 24. So this is quite simple. So if you have any question, you can ask me later. And then we have the example here, the last example. So in the example, so the first step you need to do, first arrange the data. So the lowest value we have here is 22. The next one, 22, 24, 25, 31, 31, 33, 36, 38, 40, 43, 44, 50, 53. So you need to divide the stem and the leaf. So you need to remember, leaf, we only need one digit for the leaf. So 22, you just divide it So those who have the same value, right here we have 2, so we put the number here, 2 2 4 5, 2 2 4 5. So the next row is for the stem starting with digit number 3, so 3 start from here up to here. So that's all for stem and leaf. So if you have any question, you can ask me. So this is what we have learned today. Everything is based on your book, so if you have anything to ask, please you can text me. Okay, thank you.